We all have seen this definition of formal charge in a textbook, that it is a charge assigned to an atom in a molecule. But the question is, why do we assign the charge and how to assign the charge? In this video, we will try to answer these two questions. By calculating formal charge, we try to understand if the electrons are equally shared between the atoms or not. Formal charges also helps us in the selection of lowest energy structure from number of possible lowest structure for a given species. To understand this, let us take an example of selenium oxidichloride. In this compound, we have total of 26 valence electrons and they can be these two possible Lewis structures. If you see, in both our structures, octet is completed. So how to decide which Lewis structure is more stable? Here, formal charge comes into the picture. If we calculate formal charge, which we will see shortly, in the structure 1, selenium has +1 formal charge and oxygen has -1 formal charge. But in the structure 2, the formal charges of all the atoms are 0. And generally, the lowest energy structure is the one with the smallest formal charge on atoms. So, the structure number 2 is the most stable and acceptable structure. We must remember that the formal charge calculated for an atom is not the actual charge of the atom in the molecule. We calculate formal charges of the atoms to determine if the electrons in the chemical bond are shared equally between the atoms or not. So don't ever confuse formal charge with oxidation number. This way we have answered one of the question of why do we assign formal charge. Let us move to the next one of how to calculate a formal charge. But before that, we should know the following three terminologies. First is valence electrons. Valence electrons are the ones that are present in the outermost shell of an atom. Bonding pair of electrons are the ones that are involved in the formation of bond. And the third, that is non-bonding pairs, also known as lone pairs of electrons, they are the ones that are not involved in chemical bonding. The formula for calculating the formal charge can be written as the number of valence electrons in an isolated or free atom, that means when it exists separately without any bonding, minus the non-bonding electrons minus the bonding electrons divided by 2. Let us take an example of NH3, that is ammonia. Electronic configuration of nitrogen is 1s2, 2s2, 2p5. Here the outermost shell is 2p and it has 5 valence electrons. The electrons involved in bonding are 1, 2, 3, 4, 5, 6 and the non-bonding are 1, 2. So the formal charge on nitrogen is 5 minus 6 minus 2 divided by 1, which is equal to 5 minus 5, which is equals to 0. Let us now calculate the formal charge on hydrogen. There is 1 valence electron, 2 bonding pairs and 0 non-bonding. So the formal charge on the hydrogen is 1 minus 0 minus 2 divided by 2, which equals to 0. Thus the formal charge on all the atoms are 0. Let us calculate the formal charge of the compound that we discussed earlier. The valence electrons of selenium are 6. Non-bonding electrons are 2. The bonding electrons are 1, 2, 3, 4, 5 and 6. That is 6 divided by 2. That gives us a formal charge of +1. In the case of oxygen, it has 6 valence electrons, 6 non-bonding electrons and 2 bonding electrons. That gives us a formal charge of -1. In chlorine, we have 7 valence electrons, 6 non-bonding electrons and 2 bonding electrons. That gives us a formal charge of 0. Let us look at the second structure. In selenium, we have 6 valence electrons, 2 non-bonding electrons, 8 bonding electrons divided by 2, that gives us a formal charge of 0. In case of oxygen, we have 6 valence electrons, 4 non-bonding electrons and 4 bonding electrons divided by 2, that gives us a total of 0. If we calculate the formal charge of chlorine, we will get the formal charge as 0. Thus, structure number 2 is the most stable structure among the two lowest structures. This way, we have answered both our questions about why and how we calculate the formal charge. For more such videos, make sure to subscribe our channel and thank you for watching.